All right, we are back for basic derivative rules. I was listening to these videos that I'm making, and I know they're echoey, but I think you can still hear clearly. I'm just in that little office off the makerspace, so you know, echoes in here with no carpets. So we have learned about what a derivative is. We've learned about the definition and how to use the limit definition to find derivatives at a point. We learned how to find derivatives of a graph from a graph, right? All of them being the slope of the tangent line at a point. So now we know the concept behind a derivative. Now we're going to learn some rules that you can use to help it go a little bit more quickly. So that's what this first line says, this first sentence. You do not have to use the limit definition of a derivative to find the derivative of a function because there is a shortcut. There's a short way to do it. Here's the short way. I hope I blow your minds today. Although I know some of you probably already know this, so it's not as fun. It's definitely much more fun to do in class because we put all these patterns up and then you guys notice it, but we'll see if we can do it via video. So the first thing is the derivative constant rule. If you have the derivative of a constant, the derivative of a constant number is 0. That's because the graph of a constant is a horizontal line, therefore the slope of a constant must be 0. So what this means is if you had to find say f of x is 7, right? That's just a constant function. It's a horizontal line at y equals 7. So if you had to find the derivative, which you can write like this, or you can write f prime of x, it's going to be 0. Why? Because the slope of every point on that horizontal line is 0. This is just a horizontal line. Okay. Second rule, the constant multiple rule. So if f is a differentiable function and c is a real number, then the constant times the function is also differentiable. So what this means is, say you had a function that was c, some constant, times f of x. Then if you had to find the derivative of that number, you could take the constant out, and it would just be times the derivative of x. So I'll just use this 7 example again. So say f of x is 7 times g of x. Then the derivative of f of x would just be 7 times g prime of x, right? You take the derivative of the function and then you can just multiply it by the constant. Sum and difference rule. So this one's much like the rule for when you're adding and subtracting limits. When you're adding or subtracting two functions, say f of x, f of x is equal to this other function f of x plus or minus g of x, you can just separate them, right? So you can find the derivative of the first function, find the derivative of the second function, and then add or subtract them. So pretty straightforward. So here's some examples. H of x equals 2 of f of x minus 3 times g of x plus 5. Find h prime of 3 given f prime of 3 equals 1 and g prime of 3 equals 5. So first I am going to say I am finding the derivative of x, of h of x, sorry. So I need to find the derivative of this whole thing over here. So remember, these are different ways to note that you're talking about the derivative. So that means I can first use my sum and difference rule, right, and break these apart. So I'm going to find the derivative of 2fx, and then I'm going to find the derivative of 3gx, and then I'm going to find the derivative of 5. Okay, so what's this equal to? This is equal to, I'm going to use the constant multiple rule here. I can take the constant out, 2, and the derivative is f prime of x, minus, same rule here, can take that 3 out, times the derivative of x, g of x, which is g prime of x, plus, well, what's the derivative of a constant? The derivative of a constant is 0, so that's plus 0. Okay, so I've just figured out that h prime of x is equal to 2 times f prime of x minus 3 times g prime of x. They want us to evaluate it at 3. So h prime of 3 equals, well, 2 times, what's f prime of 3? 1. Minus 3 times, what's g prime of 3? 5. So h prime of 3 equals 2 minus 15, which equals negative 13. There's our answer. All right, let's do a couple more examples before I give you the last rule. Okay, here's example 2. The following table lists the values of the functions f and g and their derivatives f prime and g prime for when x equals 4. Let h be defined as 3 times f of x minus 3 times g of x plus 2. So they want us to find h prime of 4. So first let's find h prime of x. That means I need to take the derivative of all of this stuff. Okay, and now you can break it down. I'm going to break it down. I'm going to write it all out this time. So we're finding the derivative of 3 times f of x minus the derivative of 3 times g of x plus the derivative of 2, right? Sum and difference rule there. So h prime of x equals, this is the constant multiple rule, 3 times f prime of x minus 3 times g prime of x plus the derivative of 2 is 0. So now if I'm trying to find h prime of 4, 3 times f prime of 4 is 8 minus 3 times g prime of 4 is 7. So that means h prime of 4 equals 24 minus 21, which is 3. Here's our answer. Okay, one more. So here we have x, f of x, f prime of x, and g of x equals, this is the table for f of x. And they tell us g of x is x for when x is greater than or equal to 1, and x minus 2 for when x is less than 1. Find h prime of 9 if h equals 3fx plus 2gx. Okay, so if I need to find the derivative of h of x, I have to take the derivative of this whole thing, which means I can separate this using the sum and difference rule, so I'm going to just save some space here. The derivative of 3 times f of x is going to be 3 times f prime of x plus 2 times g prime of x. Okay, now they're asking us to find it at, evaluate it at 9. So what is f prime of 9? Is 3 plus 2 times, what's g prime of 9? Okay, so now here's where I'm going to have to do some work on the side. G prime of x for when x is 9 means we are going to use this function, right? Because it's x for when x is greater than or equal to 1 and 9 is greater than that. Okay, so what is g prime of x? That's the derivative of the function x. Okay, well, what's the derivative of the function x here? What would that be? This is the same as saying y equals x. So what would that function look like if this is our xy coordinate? The line y equals x is just this line, right? So what is the slope of that line at every point? Well, the slope of that line at every point, no matter where you are, is just 1. So g prime of 9, well, g prime of any x is just going to be 1 because the slope of that line is 1 everywhere. So now I can come back over here and just say this is 1. So that becomes 9 plus 2, which is 11. Okay, so this one requires you to do a little thinking, but since it's a linear function, you should have been able to find the slope quickly. All right, the next thing we're going to talk about is the power rule. Before I give you the power rule, I want you to look at this table. So here are some functions, we'll call them f of x, and here is their derivative. Here are their derivatives, f prime of x. See if you notice a pattern before I give you the rule. So if the original function is 2x squared, the derivative is 4x. What happened from here to here? add this one to the mix. X cubed plus x squared, the derivative becomes 3x squared plus 2x. 3x squared, the derivative of that becomes 6x. And the derivative of x is 1. Kind of makes sense because we just did that. We just found that the derivative of x is 1. 6x to the 5th minus 1. Well, this is a constant, so I know the derivative of that is 0, so that went away. But 6x to the 5th became, the derivative is 30x to the 4th. And then x cubed, the derivative is 3x squared. Pause and see if you can find the patterns before I talk about them. But hopefully one thing that's sticking out to you is that if the power of the original function is, say, x cubed, the power of the derivative is 1 less. Here it was squared. Now it's just, there's no exponent. Here it was squared. Now there's no exponent. Here it was to the 5th. The derivative is to the 4th. Here it was cubed, and then the power on the derivative was the 2nd. So I'm noticing that the power is 1 less. I'm also noticing, like, here, this became a 4 in front of it instead of a 2. And I can see that there's 2 2's here, so that maybe they're multiplying or adding to get the 4. Here, I have a 3 and a 2, and that derivative came out to having a 6 in front of it. That looks like multiplication there to me. Is that true here? 6 and 5. Yeah, that gives me a 30. Here, the 3 just moved out front, so is it 1 times 3 gives me 3? So you could do that limit definition to prove these are all true. And that's what we've been doing up to this point, which would take a long time to write all these out and use the limit definition to prove that these are the derivatives. But now you can use what's called the power rule, which is going to make this so fast. Some of you probably already know it. So pause and see if you can figure out the pattern before I give it to you. So here's what the power rule says. The derivative of a function with x raised to a power is this. So if you have f of x equals x to the n, this should say f prime of x. So I'm going to write it here. Then f prime of x equals all of this stuff right here. It equals n, which is the number in the power, times that x raised to 1 power less, which is our pattern, right? So if I take the 2 and bring it to the front, it's 2 times 2, so now that's a 4, and then my power is 1 less, it's a 1. For this one, I bring the 3 to the front, 3 times 1 is 3, and then my power is 1 less. For this one, I bring the 5 to the front, 5 times 6 is 30, and then the power on my x is 1 less. It's called the power rule. It saves you so much time. So if I had to find f prime of x here for x to the 5th, I would bring the power down in front, 5. There's nothing to multiply it by. So it's 5 times x and then n minus 1, or 5, take away 1, 5 minus 1 is 4. Okay, what's f prime of x here? Okay, we can still use the power here. Let's just rewrite it. I'm going to rewrite this as x to the negative 2. Right? All I did was move it up to the top, so I'm just dealing with 1 power. So now when I find f prime of x, I bring the negative 2 to the front, multiplying it by nothing. It's just a 1 there, x. And then what is my power take away 1? My power take away 1 is minus 3. Negative 2 minus 1 is negative 3. So I could rewrite it like this if I wanted to. You don't have to, but you can. Or 2 over x cubed. I'm just going to write it like that. And then what about this? Okay, so you need to remember that this means that, right? That's what the cube root means. So f of x equals x to the 2/3. So now the same rule applies. F prime of x is going to be bringing the 2/3 to the front, x. And what's 2/3 take away 1? Negative 1/3. So you can leave it like that, or you can rewrite it as 2/3 times 1 over the cube root of x. right? So you can use this for anything. Let's say f of x was, I don't know, let's say it's 7x cubed. So first rule, bring the 3 to the front. 3 times 7 is 21. And then x 1 power less is squared, right? So you can, it's a pretty intuitive rule once you start doing that, but sometimes you get these situations where you have to change the power and make it negative, so you can use the rule, or you can break it apart like this. So you'll have to remember all those exponent rules. So today you're gonna get practice with all of this, and now you can stop doing limits to find derivatives. Hopefully you find that as exciting as I do. Okay, see you guys next time.